Welcome Algebra 1 students to Lesson 50. I'm going to talk just a little bit more about degrees of a polynomial. We know that from Lesson 48 that if we had a polynomial that looked like this, that would be a third degree polynomial. And we knew if we had a polynomial that looked like this, that would be a first degree polynomial. And we knew that if we had an expression that looked like this, that would be considered a fifth degree polynomial. All of these expressions have a single variable. So when we take into account degree of a term that has more than one variable, we have to consider all of the exponents in that term. What I mean is, if we have a term that has 3a, b, c, we have to consider this is a complete term. This is a third degree term because we have an exponent of 1 here, and 1 here. So 1, 2, 3. That would be a third degree term or a third degree polynomial. If we had the same set of numbers and variables with different exponents, this would be considered a seventh degree polynomial. If we have an expression here where we have 7a squared b plus 4c 5d2 plus 3x y3, this would be considered a seventh degree because we have a 5 and a 2 here, and that is the highest one we have. This is a 3 and this is a 4 in terms of adding the exponents together. So it's still going to be the highest term of exponents within an expression. However, if there's more than one variable, you have to add those exponents together. It's not just the highest exponent, it is the highest total exponents in a single term that determines the degree of your polynomial. The other thing I wanted to say was that if you have, let's say we have this here, let's say it equals 0. If you have a polynomial expression that has an equal sign on the end of it, this would be called a fifth degree polynomial equation. Why? Because it now has a result. It has an equal sign. So we tack the word equation onto the end of what we've already learned, and that's about as far as we can go with that. So great news. I knew that everybody was really waiting for this. We're going to start graphing. Oh yeah, here it comes. So let's talk about what is required. The first thing that is required is we need to have an understanding of the Cartesian coordinate system. We have to understand what it looks like. Let me get some graph paper in here for you guys. That's going to be very key. If I can get it to pull up. Hang on. Here we go. Squared paper. There's some graph paper. All right, so a coordinate system, it looks like a line here and a line here. Just like that. And we have an area of our page that is divided automatically with these two lines into 4 sections. Now, the name of this system is called the Cartesian. That was my dog. He's like snoring in his sleep. Just ignore him. This is called the Cartesian coordinate system. And if you notice, it starts with the letter C. There's a reason you want to take note of that. we have noted that there's 4 sections. We call those sections quadrants. This is quadrant 1. This is quadrant 2. And yes, I'm using Roman numerals. This is quadrant 3. And this is quadrant 4. Why is it numbered like that? I don't know why it's numbered like that. But I do know that if you draw the letter C for Cartesian coordinate system, the place where you start is 1, and then it goes through 2, 3, and 4. And that helps you remember the order in which they are numbered. So when I say quadrant 1, you know that's where you start drawing the letter C. Quadrant 2 would just follow the one after. Quadrant 3 would be almost before you're done, and quadrant 4 would be where you stop. So that is a good way to remember the numbering system of the 4 quadrants. So let me back up a little bit. Come on. It doesn't want to back up. Yeah, so I'm just going to have to erase it. All right, as good as I can. Because I really don't want to have to draw those lines all over again. All right, something to be aware of within the coordinate system is that there are 2 major lines here. Now, I want you to recognize this line, this horizontal line that goes across. This is our original number line. The original number line starts at 0 right in the middle here, and then it goes 1, 2, 3, 4, 5, just like normal. This way is positive, just like the normal number line. This way, to the left of 0, is negative. Negative 1, 2, negative 3, negative 4, negative 5, negative 6. So this side is negative. Okay? Now, this is called our x-axis. Now we have, and this is the horizontal. This is the number line we're used to using. Now we have another number line that goes vertically. It goes up and down. And this is going to be called our y-axis. Okay? And it does the same thing as our x-axis does, but it's positive when you go up. Think about climbing a ladder. You're adding some height. So this is positive this way. When we go this way, when we go below the regular number line, it becomes negative. So think about digging a hole, right? You're going under. You have less and less and less the further down you go. You have less dirt in the hole. So this is the negative side. Now, whenever we look at this axis and this axis, we can actually find points in relationship to each one of them. Let's say I want to use this on a map or something, and I want to denote a certain place on the map. That place is marked by a number here, which would be 1, 2, 3 on the x-axis, and a number here on the y-axis, which would be 1, 2, 3 as well. And we would write that as a point with an ordered, what we call an ordered pair label. An ordered pair just means that it is in a specific order. And that order is going to be x and y. Sorry, I don't know why I wrote it like that. So let me move this actually. Instead of having it at 3 and 3, so it's hard to see, let's put it at 3 and 2. So now you can see the value on the x-axis is 3. The value on the y-axis is 2. When we write an ordered pair, it is always x in the first spot, comma, y in the second spot. Always, always, when we call out a point, that's what we're going to do. All right. Something else to note is that quadrant 1 is always positive x and a positive y. This side has positive and positive. So our coordinates here are positive, positive. Always, 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 always. In quadrant 2, our x becomes negative and our y is still positive. So whatever number, you can just look at a number and know which quadrant of the map it's on, or which quadrant of the Cartesian coordinate system it's on, by looking at whether it's negative or positive for the x and the y. Now in the third quadrant, down here, we have a negative x, and then we have a negative y. So it's negative, negative over here. And if you look, it's completely opposite. They are opposite of each other. We have positive, positive in the first one, negative, negative in the third one. We have negative, positive in the second one. Guess what? Over here, we're going to have a positive x and a negative y in the fourth quadrant. Okay? All right, I know this is a lot to take in. That's okay. I know you guys can do this. You guys are exceedingly smart, and you can take all of this in. There is one other thing that we need to talk about, and that is called a linear equation. A linear equation is an equation that has an x and a y variable in the equation, and both of those variables are only to the first degree. So for instance, if I had 3, or let's say I wrote a 2 and I said 3, you can tell it's 1030. So if I said 2x plus 3y equals 4, we would consider that to be called a linear equation. Why? Because you could draw a line on the Cartesian coordinate system using that information. I'm not going to go into that in this lesson, but I want you to see the components of a linear equation. With a linear equation, you have an x and you have a y, and they are both to the first degree and only to the first degree. You cannot have an x square or a y square in a linear equation. So you will have a constant with the x to the 1 degree, and a constant or a whole number with a y to the 1 degree, and then it'll be equal. It will be equal to something. It is a linear equation, and it'll be equal to some other number. And this number will not have a variable. There are no other variables in this linear equation. That's very important to remember. So we could say 7y minus 2x equals 8. That would be considered a linear equation, because using the first degree of y and x set equal to a number with their own coefficients, we can draw a line. And we'll get into that more in the next few lessons, and we'll go over that and how you can do that, because it actually gets pretty fun. Write all of this down. Don't forget about drawing your C, or writing the letter C to help you remember the order of the quadrant numbers. 1, 2, 3, 4. All right, and then don't forget your signs in each one of these. What did I do that for? Well, I'm just going to have to rewrite it. Positive, positive in the first quadrant. What I meant to do was this right there. So positive, positive, negative, positive, negative, negative, positive, negative. All right, those are important. It's also important to see how we label them. X is always the first one. That's this example here. Y is always the second number. So if I were to give you a coordinate, let's use our red pen, of -4, if I can get it to write, -4, +3, that would be in this coordinate because it's a negative positive. So I'd go 1, 2, 3, 4, and 1, 2, 3. That would be -4, +3 right there. All right. Let's say I have another one. Let's say I'm going to do, my computer's thinking, okay, that's good. That color's good. Let's say we want to do -2, -5. That's a negative, negative. It's going to be in the third quadrant. -2, and then down, because this is a negative, we want to go down. 1, 2, 3, 4, 5. So this would be -2, -5 right there. And whenever we draw a point on our chart, we want to label it with our coordinate. We always want to put our label on there. So what we want to do is write this right next to it. So we would say -2, -5 right next to our point, right? What if we had a positive negative? Let's get this green pen here. Let's say we had a +4, negative, let's do -1. So we'd have positive on the x-axis, 1, 2, 3, 4, and a -1. And then we would label it 4, -1, just like that. So that is how you would find points on a Cartesian coordinate system. These are the components of a Cartesian coordinate system. And this is the format that we consider a linear or a line equation, or the equation of a line. Now there's going to be some more formatting things that we have to do to it in order to draw that line, but knowing the components, knowing that you have to have y to the first degree, x to the first degree, and that's it, equal to some number, that's important, so that when you look at a number, when you look at an equation, you know that's a linear equation. I can draw a line with that. It's pretty cool. We'll move on to that in, I think it's lesson, oh goodness. Yes, it's the next lesson, lesson 51. We'll start drawing some lines. But that is all we have for lesson 50. And I'll see you guys in lesson 51.